Okay, let us continue with the video. Alright, as we can see here, alright, let me box it up. Okay, as you can see for this is our dy dx. So we say that dy dx is more than 0. So the question given that dy dx is more than 0, and then I want to find the range of A. So this is our question, and if we see from here, we say that okay, we know that the denominator, this is always more than 0. But how about this? It seems that when x change, A change, and it's very hard to determine whether it is more than 0 or less than 0, right? Because when x is a different value, A is different value, then the denominator will be a question mark. So what we want to do here is we want to complete the square. So every time we face with this, we want to complete the square. So what happens when we complete the square? The final answer looks something like this. So this is my final answer. And let's look at the steps. So this is the steps for completing the square. So we scroll further down. Okay, we say that you need to add half the coefficient of 2ax, and then minus a square. So then after that I will have this, after that I will have this, and from here we learned that we can break up the fraction, and after we break out the fraction, we have something like this as a box in the blue box. Okay, so let us take a look from here. Now, when we say dy dx equals to the red box, it seems that it is very hard to determine. But when I say dy dx and I simplify it as a black box, as a blue box, you see that, let's analyze. 1 is always positive, the denominator is always positive. So the question is, what value must A be so that the whole dy dx is positive? So we say that for y to be increasing, what is the value of x so that dy dx is positive? Or rather, when dy dx is positive, then we can say that it is a increasing function. So the question now is, what is A? So you can see that I don't care what is A, because if A is negative, the whole thing square will be positive. When A is positive, again it is positive. Therefore the answer will be for all real value of A.